Hey guys, coming at you with a horrifying video about math. And we're getting attacked by the evil eggplants. Or we're just talking about triangle midsegment theorem. So we're going to talk about triangle midsegment theorem. What it is, and then we're going to do a couple of examples. So let's take a look. Okay, first. What is a triangle midsegment theorem? If a segment joins the midpoints of two sides of a triangle, then those segments are parallel to the third side and half its length. It's good to know that this is a special case of the triangle proportionality theorem. And also, don't forget, the term theorem means a theory proven true, so it's always the case. So let's take a look at what that means. Okay. First thing I want you guys to recognize is that this is a theorem that's proven true, so it's always the case. The ancient Greeks probably figured this out, and it probably helped them in building things and solving whatever specific problems they had. Keep in mind, they didn't have fancy computers or anything like that. So, what I did is I drew this triangle here, and I drew this length here at 6 inches. And I marked E at 3 inches. So that means this length here is 3 inches, and this length is 3 inches. Then I drew this length at 4 inches, and I marked D at the 2-inch point, so in the middle. So this is 2 inches, and this is 2 inches. So these pieces, like YE is congruent to ZE, YD is congruent to XD. So now I'm going to measure this length here. And it's at about 2.5. It's slightly longer than that. Okay, so 2 1/2. 2 1/2. There you go. Okay, 2 1/2. So now when I measure this length down here, you can see it's roughly at 5 inches. It's slightly longer, but in essence, it's double the length. So this is half the length of this, or this is double the length of that, however you want to look at it. And it's a result of E being the midpoint of these lines. So now, how does that affect you? Well, you get questions like this that ask you to solve for X. So my first hint that I'm going to look at, or my first detail, is that I got congruency marks here. And as a result of that, I know that I'm dealing with a triangle midsegment theorem question. So I can multiply this by 2 and set it equal to that, just like I can here. 2.5 times 2 equals 5. So that's what I'm going to do. So 2 times 2x minus 13 equals 2x minus 8. I distribute my 2, so I get 4x minus 26 equals 2x minus 8. Now I'm going to subtract my 2x. I always like to move the smaller x over so my x's stay positive. Then I'm going to add 26. So just double checking, negative 8 plus 26 is 18. Then I'm going to undo this multiplication by dividing by 2. And x equals 9. Okay? So then, that's it. We're going to look at the next example. All right, let's take a look. So this question is being a little bit more specific. It wants me to find this length here specifically. Now again, at first glance, this looks like a triangle proportionality question with all this stuff going on here. But then I noticed the detail of the congruency marks. That's telling me that W is the midpoint of ML and V is the midpoint of MN. As a result of that, I know that this is half the length of that. So I can set this up by multiplying 2x minus 11 by 2, which is the shorter guy, and setting it equal to the longer guy, 2x minus 6. I'm going to distribute the 2. Then keep it equal to my 2x minus 6. I'm going to subtract my 2x to bring it to the other side. Right, that's going to give me 2x here. I'm going to add 22. And I'm just going to double check with my handy calculator. So, negative 6 plus 22 gives me 16. Then I divide by 2. And x equals 8. But I am not done yet. I have to plug this in, right? Because I need to find the length of WV. So I'm going to plug in 8. I'm going to plug in 8. There's my plug. Okay, I'm going to plug in 8 into 2x minus 11. So 2x minus 11. Then I'm going to plug in 8. So now I'm going to have 16 minus 11, which is going to give me 5. Okay, check this out. I can check this. Because I can plug, even though the question doesn't ask it, I can plug that into this one and double check. I mean, we know that this is half the length of that. So if I did this correctly, this will be 5 and that will be 10. Let's take a look. 2x minus 6. 8 minus 6 gives me 16 minus 6, which then gives me 10. So now I know it works. And I'm also an overachiever. Okay, next. Last question. This is a standardized test question, just so you guys know. In the given triangle, D, E, and F are the midpoints of the sides. What is the perimeter of triangle ABC? There's a couple of ways to do this. The first way is to add these up and then multiply the perimeter by 2. I can totally do that. I want you guys to recognize the relationship of the sides, so I'm going to do this the long way. So if this is 6 here, if FE is 6, that means AC is 12. If DE is 8, then AB is 16. Then 7, DF is 7, that means CB is 14. I knew all of that because of this. They told me it was the midpoint, so they're saying it's a mid-segment theorem. So now I knew that. And remember, it means the sides parallel. So I'm applying that definition or that theorem to get this done. So now I got to find the perimeter. So 12, 14, 16, and you add up the sides. That's how we find the perimeter of any shape, is we just add up the sides. So 12 plus 14 plus 16 gives me 42. And just for the record, to find the little guy, I add that up. If everything is correct, if the theorem is true, then this should be 21. Well, 8 plus 7 plus 6 turns out to be, ta-da, 21. Okay, guys, that is the video on triangle mid-segment theorem. I hope you found it helpful.